Hello everyone. In this video we are going to see if we store a large piece of information in a variable, what will happen? Like if a variable is having a particular range and if we are going to assign a beyond range data to that variable, so what that variable actually stores. So let me start with a very simple variable. So let's say we are having a variable and this variable is having 3 bits in memory. Okay, so in the previous tutorial we have seen how to find out range of a variable. So the range of this variable for unsigned is -4, -3, -2, -1, 0, 1, 2, 3, or in signed range 0, 1, 2, 3, 4, 5, 6, 7. So now let's say I want to store 8. Okay, so if we see the binary of 8, so the binary for 8 is 1000. Okay, so this is binary of 8. So when you try to store 8 in this variable, so when you write a equal to 8, so a is having only space for 3 bits, but the data you are assigning, that data is having, that data actually requires 4 bits. So what will happen? This bit will be stored here, this will be stored here, this will be stored here, and for this one there is no space. So in a, what is stored in a is stored 000. So when you try to printf this value, what it will store, it will print 0. So the thing is that you cannot store any value beyond the value listed over here. So this is the normal case. Now let's have a look in the case of C programming. So in C, let's say I'm having a variable int a, and in C, this integer variable needs 2 byte, and the previous tutorial I have shown you the range of this variable is 0 to 65,535, which is unsigned, and in case of signed it is -32,768, 0. So what I want to see, if I write here 32,768, what will happen? Okay, what will happen here? Okay, so in order to understand this one, let's have the similar situation for this one. So let's say this time we are having a unsigned a variable. Sorry, this is signed variable, not unsigned. So signed, the range of signed variable is this one, -4, -3, -2, -1, 0, 1, 2, 3. And what I want to do, I want to assign here 4. Okay, so a is having 3 bits space. So first of all, find out the binary for 4. So the binary of 4 is 100. So when you write here 100, now this is a signed variable. It means the first bit of this one will represent whether this is a positive number or negative number. So it means if there is a 1, it means this is a negative number. Okay, now we know that this number is a negative number, but what is this number? So what you have to do in order to find out the value of that number, just apply the 2's complement on this number, and the number you will get, that will be the negative number. So the 2's complement of this number is the same. This is the 2's complement. These calculation, these computation, we will see in the next tutorial how this is calculated. For time being, 2's complement is every bit will be reversed, and in the outcome 1 will be added. So this is the 2's complement of this number, and this is 4. So this number, we can say this number is minus 4. Now let's say if I want to store here 5. So let's say signed a equal to 5. So in case of 5, binary for 5 is uh, what is the binary for 5? 101. This is the binary for 5. So this will be stored in A. Now again, first bit is 1, it means this is a negative number. See, we are storing positive number, but because this is a signed variable and this variable is having a particular limit, and if you're trying to store a number beyond that range, so there will be some complications. So here this 5, how this 5 will be represented? So in this binary presentation it will be considered as a negative number. And what is this number? So just apply 2's complement on this, and the 2's complement of this number is, sorry, 110, which is 3. So when you store 5, it will be converted automatically, or it will be represented as minus 3. So see, these value actually working in a circular fashion. If you go one more than this number, you will get minus 4. If you go two more than this number, you will get minus 3. If you will go three more than this number, which is 6, so if you store 6 and if you print your value, you will get minus 2. So similar thing actually happen with integer variable. Let me clean this one for you. So same thing happen in case of integer variable. So in integer variable range, we have seen minus 32,768, 167, and so on, then 0, then 32,767. So this is the range of integer data type variable. So if you are going to assign one more than this number, so it will work in a circular fashion, and the next value from this will be considered this one. So if you print this value, it will print this one. So you can consider these value in a circular fashion. Let's say this is 0, 1, 2. So here 32,067, this side minus 1, minus 2, minus 3, and here minus. So when we add 1 in this number, we will get the next value. So similarly, when you try to store 32,768, which is after this one, so after this one, what is that? This number will be represented. Okay, so similar case, if you go for, let's say, 69. So in order to reach 69, what you have to go? You have to go 32,767, then next to next. So that value will be minus 32,767. Okay, so so the thing is that when you assign a data which is bigger than the memory, in that case some part will be lost. Okay, and how that assigned value will be represented? So this is the way you can consider it in a circular fashion. So in the next one, I will show you how a number is represented in binary, particularly negative number. Thank you very much for watching.